Cold startup, our next PID. Cold startup, one of the toughest emissions that manufacturers face is keeping the engine from polluting the air when it's cold. Cold engine requires more fuel. More fuel means more hydrocarbons that pollute the air, more carbon monoxide that poison the air. So how do we reduce the hydrocarbons and the carbon monoxide? Ideally, at one time, the plan was to use electrically heated catalytic converters. So you would get in a gas engine, turn the key on, it would say wait. Immediately you would think, well, is this a diesel engine? Am I waiting on an intake air heater or glow plugs? No, you would be waiting on an electrically heating grid to heat up the catalytic converter. We never got around to those, especially because we never made it to 36-volt batteries. So we had to use the technology that was on the engine. And the technology we decided to use, which could be triggered by this cold startup at a certain temperature, is we can fire the injector twice. We can control the exhaust valve opening. We can add additional fuel to heat up the catalytic converter on a cold engine. By utilizing variable cam timing, holding the exhaust valve open longer, and firing the injector maybe a post-event a second time, we can use that additional fuel to quickly heat up our catalytic converter. It doesn't take very long on these late model modern variable cam timing direct injected engines for that catalytic converter to get up to optimal temperature. And that's how we meet cold engine emissions, which is part of that cold startup strategy. Mass airflow sensor. Regardless if it is turbocharged or naturally aspirated on a GM, GM is utilizing a pretty fancy mass airflow sensor. It can be quickly identified because it has 8 wires. The 2 vendors supplying these mass airflow sensors to General Motors are Hitachi and Bosch. They both have 8 wires. They're not wired the same. The wiring is configured differently, but they do the same thing. One, just as always, as you can see here in mass airflow rate, we're down to a base idle, hot engine. Our grams of air per second is 2.14, 2.15, hanging right around 2 grams of air per second. This engine is only 1.5 liters, so it doesn't take much air to keep it running at a base engine hot idle. So we still have a frequency output that equals the grams of air per second in the mass air transfer function. We also will have this 8-wire mass airflow sensor, and some techs aren't even calling it a mass airflow sensor anymore. They're calling it a weather station. It has 2, a high speed and a low speed air temp input to the computer. It can input barometric pressure. It can input humidity. So now we're going to see a barometric pressure sensor signal on this vehicle coming up that is coming directly from the mass airflow sensor. Also, we will see a PID that we've never seen before on this late model engine. With the 8-wire mass air, we have humidity. So here you can see mass airflow in grams of air per second. If I scroll up a little bit, there's our barometric pressure. Where did that used to come from? It came from the key on engine off or wide open throttle from the manifold absolute pressure sensor. Now we're constantly reading barometric pressure from the 8-wire mass airflow sensor. And there's our new one. There's calculated barometric pressure, an input from the 8-wire mass air, ambient humidity. So it now knows the moisture content in the air. It knows the weight of the air in grams of air per second. The moisture in the air, the weight of the air, the altitude in which route, the outside ambient pressure. It's all in a gulf. The computer knows all this information. Don't you think it has a pretty good idea of the amount of oxygen that's available to utilize, because it's oxygen that is utilized to burn the fuel. So it's got a very accurate amount of information to keep our air-fuel ratio more accurate today with this 8-wire mass airflow sensor than it's ever been in the history of the automobile. Accelerator pedal position. Because we're drive-by-wire, we don't have a cable connected to the throttle body. What we are is electronic throttle. And the truth of the matter, being that this is a 2020 vehicle, that this engine is programmed from the engineers at the factory in what's called torque-based. The driver is suggesting to the computer how much torque output this engine should provide, and that comes directly from the pedal position. Inside the programming will be a driver demand table, which is pedal position versus torque output. So the computer has a desired torque that it expects to reach based upon the accelerator pedal position. The old throttle position sensor, what was it? The throttle position sensor was the accelerator pump of fuel injection. To get this 3,000-pound vehicle into motion from a stoplight, we needed an extra shot of fuel. So the computer would look at the TPS, the throttle position sensor, and as it would move, it would go into an asynchronous firing of the injectors, adding additional amount of fuel. It doesn't work that way nowadays. The throttle position sensor, one of two or maybe three pieces of information, are a direct feedback to the computer that the throttle did what the computer told it to do. The throttles are controlled by electric motors that are in charge by the computer. The computer is watching the driver demand, the pedal position sensor. So acceleration enrichment is now controlled by the pedal position sensor. If it sees driver demand, once that pedal moves, it's going to enrich the mixture. And right away, it's going to look for a desired torque level based upon the engine RPM, the engine load that's configured from mass airflow, and possibly speed density, because this engine has both speed density and volumetric, meaning it's doing a calculation with the manifold absolute pressure sensor at the same time that it's doing the calculation with the fancy 8-wire mass airflow sensor. So really, throttle position sensors, we could have up to 3. We may have one that's low, like always, at closed throttle at idle. As we increase the throttle, or it comes open, the voltage rises. We may have a backup throttle position sensor that may be a volt off of that line, meaning it's a little higher voltage, or we may have one that's 4.5 and it drops as we increase voltage. It depends on how the engineers wanted to feedback the throttle position voltage feedback, but we have redundancy, we have backup, because all 2 or 3 throttle position sensors have to match. If they don't match what the driver's doing, the nut between the seat and steering wheel with the pedal, then we're going to end up going into some sort of a limp-in mode, because the computer is going to be afraid that it doesn't have control of the drive-by-wire throttle system. So the accelerator pedal position is probably more than just one position sensor. As I said, we have a lot of redundancy, a lot of backup strategy in case there's a failure in that electronic throttle control system.